Hello, welcome to another briefing. I just wanted to start out by showing the playback on the satellite imagery for the Bay Area today. I tend to focus a lot on the Bay Area since this is where I'm based. You can see we had can't really tell in just from looking at this, but today we did have a little coastal eddy, which is sort of a small scale little low pressure system that develops when we have very strong northwest winds over the waters off of the Bay Area. And as a consequence of those winds, you have a lot of upwelling which is what happens when the wind hits the terrain and then goes back over the ocean, and that shaves off the surface layer of the water, which is warmer, and it allows colder water from below to upwell to the surface. And as that is happening, as the winds are hitting that terrain and then moving back over the water, that creates sort of a spin over certain areas, and that facilitates the formation of what we call a coastal eddy. And we had one today. You can sort of tell very lightly because it's pulling in a low pressure system in the northern hemisphere. We'll have clockwise winds. It will have counterclockwise winds. If it's a low pressure system in the northern hemisphere, it's counterclockwise winds. High pressure have clockwise winds around it. But anyways, you have the northerly wind. So the eddy, it's right west of the Golden Gate here. So you look at the Golden Gate here with the mouse, you go right west of it. This is where the eddy is. I'm going to show the animation again. See, if you pay attention as I put this into motion to right west of the Golden Gate, see that circulation right there, and then look at that strip of clear sky to the left of the eddy. That's where the north wind would be wrapping around this low pressure center, and north wind tends to be drier, and it'll bring drier air from up above these mountains down towards the surface, even down towards parts of the ocean where you have where you'll notice that drying taking place. There's thin layer of drier air mixing down to the surface and evaporating those clouds. But the main thing that this circulation did today is it kept a southwesterly flow through the Golden Gate Bridge into the city of San Francisco, and a pretty strong westerly flow elsewhere, and slight southwest into Santa Cruz as well, which kept low clouds hugging the coastline. Particularly southwest-facing slopes had a lot of steady influx of clouds throughout the day today. Sausalito, for instance, where I'm located, right north of the Golden Gate Bridge. Usually we see clearing in the afternoon. We only had partial clearing today, with a pretty steady flow of onshore wind and ocean clouds. Today, coincidentally, was also our 4th day in a row below 70 degrees. And this time of year, we have an average high of 75. So it's been at least 5 degrees below average. It's actually been as low as 12 degrees below average certain days this week. I believe we had a day where it was only 63. Today was only 65. So 10 degrees below average again today, and that is due to this flow. Not only the lower pressure system aloft, which allows the marine layer to deepen and the onshore wind to push further inland, but this little coastal eddy feature keeping low clouds over coast and bayside areas today really kept those temperatures much cooler for a lot of the Bay Area today. And if we just take a look at that briefly, I can show you here what the maximum temperatures were throughout the Bay Area for today. So you can see much of the coastline and even bayside areas, only 60s, some low 70s in some parts. You had about you had upper 50s for the western part of SF. You had about 63 degrees downtown. Much of the peninsula moving down towards San Mateo and the Palo Alto area, only about 65 to 70 degrees. San Jose, only 82 degrees today, only 80 in Livermore. This time of year, the average is usually still in the upper 80s, if I'm not mistaken. Fairfield, only in about 80. You have to go well inland to Sacramento. And then you, see, no, this is not loading, but, okay, here we go. So, all the way to Sacramento for you to see anything near 90 degrees today. So, that means there was quite a bit of an onshore wind, as you can see here. So the next thing I wanted to show is we did have some thunderstorm activity over Southern California today. And this was due to this low pressure system, and you can see the negative pressure heights anomaly. Basically the pressure at 18,000 feet, how much air is pressing down on the surface. And you can see a low pressure trough here, which means a very light atmosphere, and it also allows colder air. It's usually associated with the trough, which allows colder air from the polar regions to dive down to the surface and to the lower latitudes. And it also allows for a deepening. That lower pressure allows for a deepening of the marine layer at the coast, and the ocean air ends up penetrating further inland. But low pressure, cold air aloft also creates a lot of lift and instability. And with a little bit of moisture that we had tapping in from the Gulf of California, we did have thunderstorms triggered over Southern California today, as this low pressure center makes its way over the Blythe area, the desert southwest, going from California into Arizona. You can see on this radar animation here, you can see that circulation, that counterclockwise circulation around the low pressure center as we went through the afternoon hours today, and that those rain showers affecting a lot of the desert southwest and the mountains of Southern California. So, I wanted to put this computer model projection into motion. This is based on the conditions as we best understand them today. This is a projection of the European model. This is basically the control run for the European ensemble. The ensemble is basically taking the initial conditions as we best understand them, and then tweaking them, creating, basically it has 50 different members where we do basically 50 different little changes to the initial conditions, and then projections based on that. And we have what we call the ensemble mean, which is kind of the average of all of those projections. And we have the control run, which is basically the member number, whatever member number one is projecting, that's what we call the control run, based on the conditions as we best understand them, without any major tweaks. And you can see this projection as we put this into motion. As we go through this weekend, you notice this ridge of high pressure. Notice these higher than normal pressure heights starting to build into California, and this ridging pattern here. And this is warm air. This is a lot of sinking air, which is going to be moving down the mountains, compressing and warming. This is a warming air mass aloft. And if you consider the winds, another thing I really wanted to show you here is the wind field. I'm going to zoom in a little bit to see more of the western United States. And I'm going to put surface pressure on here in the parameter. And I'm going to show you this. So see how we have, so the darker colors are higher surface air pressure, and the lighter colors are lower surface air pressure. And remember what I said about the winds going clockwise around high pressure and counterclockwise around low pressure. So here you have basically an area of higher pressure that's pushing into a lot of the Pacific Northwest and the state of Idaho, parts of Nevada, Utah as well, into Wyoming. This is high pressure, so imagine a big H over Idaho here. And then you have a low pressure system over much of California, particularly the southern half of California. So with the high pressure over Idaho and a low pressure here over SoCal, you have a pretty northeasterly wind direction here in between those two systems, because it's wrapping around the low, and you would have the northern side of the low, you have kind of an east northeast, with when you couple that with the circulation around the high, that's going to be a not very significant, it's not very strong high pressure here, but it's enough for a light offshore wind event. And when you get that offshore wind in addition to the warm air aloft is when you can heat up all the way to the coastline, because that marine cold layer of air gets pushed out by those offshore winds. And you'll be able to see what I mean when I show this projection for the temperatures over the next couple of days. So this is Saturday. You see a lot of 70s for the Pacific Northwest. You see 80s for Northern California, 90s down the Central Valley. Pretty average weather, but then going into Sunday, looking at heating up a few degrees from there. And you go into Monday, and we get close to 100 for some parts of the Central Valley, and we have 90s and even some 80s. It looks like almost to the coast. If I just put, I just want to show you a little more detail. So I'm going to go into the Bay Area. I'm going to get, so I just want to show you, yeah, here we go. So this is a Bay Area projection. This is for Monday. This is per the National Blend of Models, basically taking all the computer models we have out there and doing a super blend, and it comes up with these numbers. And we have 70 degrees in Half Moon Bay, which is pretty significantly above average for Half Moon Bay. 76 by the water in Monterey as well. That's quite warm. And this is just an average of all the models. But some models are showing even hotter. The European certainly was, and when I looked at the earlier today. So let's go to the same time frame we were looking at. This is the maximum temperature for Oh, okay. So I think I was looking at the wrong one. Sorry. So this is the maximum temperature for Monday. And look at that, 76 degrees on the European model for Half Moon Bay, and 80 degrees for Monterey. This is very warm air all the way to the coast. So you can definitely see the indication, as the European model was showing on the pressure field, there's strong indication for that offshore wind event here too. Let me just show you. I'm going to go back a little bit. I'm going to show you the winds at 11 a.m. So at 11 a.m., even late morning, you still have, look at this. This is a northeast wind. This is offshore wind. And this is going all the way out to the coastline. See this like easterly component all the way basically to the coast. If you go earlier in the day, you're going to see even like look at 7 a.m. you're gonna see this offshore wind straight up all the way to the coastline. And then it starts to shift sort of northwest, so a bit more onshore at the coast by the time you get into the afternoon. But notice, at least on the European model, this is not a lot of wind. This is very light. And then maybe up to about 10 miles per hour. That's still pretty light. That's not very significant considering how windy it can get in this area. A little bit of an onshore push, but mind you, when you have warming air all the way out to the water, that water is going to slowly warm up as well. It's not going to warm up as fast as the air above it, but the air above that water and that water are going to slowly warm up as well. So once the sea breeze does kick in, that water isn't as cold. So it's not going to have as much of a refrigerant effect. It won't be able to cool off the areas that it does penetrate as quickly and efficiently as it would if that water were colder. So this does tend to happen a lot when we get offshore wind events, particularly for a couple days in a row. The cold water itself starts to warm up a little bit, and the air around it consequently. And that means the sea breeze becomes a little bit less effective in cooling. Thankfully, we are still expected to get a bit of a sea breeze on this day, so there will be some cooling, at least some minimal cooling near the coastline. But it's something to keep in mind. We do have a big heat up forecast coming up. Another thing I wanted to show you, just the last thing, is the possibility of snow on the National Blend of Models. This is as we're going in towards the late week, towards about the 27th. We have a pretty cold system that's going to be dropping into the Pacific Northwest and British Columbia around there. So around then, if I put this into motion, you'll see as we go all the way to the end of the model run, at 5 p.m. Pacific on October 1st, you see quite a bit of snow for the highest peaks of British Columbia. You can be looking at the max value, almost 30 inches of snow. And over here, a lot of the Canadian Rockies as well, and even parts of as we look at mostly the western half of the United States, even parts of the Tetons. There is a pretty significant system expected in Colorado the next few days. And if you do zoom a little further out to include Colorado, you'll see some of these pretty hefty amounts in Colorado too. You're talking the very highest peaks above 10,000 feet. Some of those peaks could get over a foot to potentially 20 inches or more of snow. Even like it's showing a max of 34 here for the very highest peaks, the probably southwest facing, because the storm is supposed to come in from the southwest. So that's all I have for today. I know this is quite long, but I wanted to give a good overview of what's expected over the next 5 to 7 days. I hope this video was helpful. I hope you were able to get something out of it, and thank you for watching.